Hello, in this tutorial we will see how to perform ARMA modeling in Multimodeler software. Uh, Multimodeler supports two types of ARMA modeling. The first one is ORS based and the second one is MLE based. We will, in this tutorial, we will perform MLE based ARMA modeling. So let's open our time series data from the XLSX file. Here we have four time series data: CPI, USD TRY, Euro TRY and Brent series. And we can open the MLE ARMA modeling panel by clicking on this MLE ARMA button in the toolbar like this. In this panel, in the left hand side, we have the names of the series and we will select the series which we will model in this panel. And in the right hand side we have ARMA modeling parameters. Basically we have two modes. One of them is manually entering ARMA degrees. We can enter P and Q values of the ARMA model by using these entry boxes in manual mode. And we can also have perform the automatic selection of ARMA degrees. In this case, we will set the maximum value for P and Q, and we will also set the selection criterion for the best model here, AKK information criterion or Bayesian information criterion. And we also have optimizer selection here. One of them is BFGS and the other one is artificial bee colony algorithm. If we use BFGS, we need to use optimization multi-start because it may reach local minimum. But if we use artificial bee colony, it automatically finds the global minimum. So we don't need to use this optimization multi-start property. And we also have optimizer tolerance setting here, maximum number of optimization iterations, and the Luyung box selection. So let's model the Brent series using manually entering the P and Q, and let's perform for P is equal to 1 and Q is equal to 1 using artificial bee colony optimizer. And we just need to click on the Run ARMA Modeling button here. And as you see, ABC algorithm finds the model very fast. In the start, we have information about the selected series and the model, which is followed by AIC and BIC values, optimization diagnostics, number of iterations, etc., and coefficients of the model and ARMA equation here, and then we have root diagnostics here. So ARMA roots are stable and MA roots are invertible, and then we have model fit statistics here, the coefficient of determination and other statistics, and an extensive list of error metrics, and this is followed by residual diagnostics here in this section. And finally, we have the actual, the fitted and residual values in tabular format. In the next step, we have the actual and fitted series here in the same axis. We have residuals plot and we have ARMA forecasting functionality. So we can calculate forecast values for this Brent series, just entering the forecast horizon and clicking on the Run ARMA forecast button like this, and it uses the model we just calculated and it calculates the forecast values. And we also have the forecast plot. Blue one is the actual data, green one is the model fit, and red dots indicate the forecasted values. We can also perform automatic degree selection for MLE ARMA. we just need to set modeling method to automatic selection of ARMA degrees here. And the maximum automatic degree is 3 by default. Let's run the model with this default value, and we just click on the Run ARMA Modeling Model button. Here the software is now calculating all models starting from 0, 1 to 3, 3. So there are lots of models to calculate in this case. Now all models are calculated after a couple of minutes, and we have AIC grid here and BIC grid here for P values and Q values in columns and rows, and we have AIC and BIC values in matrix format. So for this data, the software has selected, let's check, the model with P is equal to 1 and Q is equal to 1, and AIC and BIC values for this model is reported with all the parameters having the same format as in the manual mode, and we have the actual and fitted series plots in this tab, residuals plot in this tab, and also we need to calculate the forecast again for the new model like this. Thanks for watching.